Let's explore how classification models work in machine learning, breaking down the theory and mathematics in the simplest way possible. Classification models separate data into distinct categories, like sorting objects into different boxes based on their features. Let's start with the basics of what classification actually means. Classification is about assigning data points to predefined categories or classes. Think of spam detection in email, diagnosing diseases, or recognizing objects in images. The model takes input data and predicts which class it belongs to, like sorting items into box A or box B. The simplest classification model uses a straight line to separate classes. We draw a decision boundary, a line that separates different classes. Points on one side belong to one class. Points on the other side belong to another class. Our goal is to find the best line or boundary that cleanly separates the different classes of data points. Now let's look at the simple math that powers classification models. The decision boundary is described by the equation y equals w times x plus b, just like a line from basic algebra. Here w is the weight that determines the slope, and b is the bias that shifts the line up or down. If w times x plus b is greater than 0, we predict class A. If w times x plus b is less than 0, we predict class B. The process flows from input features through our linear function to produce a class prediction. The model learns by adjusting its parameters to minimize mistakes. We start with training data that contains examples with known correct answers or labels. The error is the difference between what the model predicted and the actual correct answer. The model gradually adjusts its weights to reduce this error, getting better with each iteration. Like a target getting smaller, the model's errors decrease as it learns, converging toward the optimal solution. Most classification models output probabilities rather than hard yes or no decisions. Using the sigmoid function, we convert our linear output into a probability between 0 and 1. The sigmoid function creates this S-shaped curve, smoothly mapping any input value to a probability between 0 and 1. If the probability is greater than 0.5, we predict class A. If less, we predict class B. For more than two classes, we extend the same idea. For multiple classes like cat, dog, or bird, the model outputs a probability for each class, and we choose the one with the highest probability. These probabilities sum to 1, ensuring a valid probability distribution across all possible classes. We need to measure how well our classification model is performing. Accuracy is simply the fraction of predictions that the model got correct. Accuracy equals the number of correct predictions divided by the total number of predictions. A confusion matrix shows us true positives, false negatives, and true negatives, giving a complete picture of model performance. Let's recap what we learned about classification models. Classification models assign data points to categories by learning decision boundaries from examples. The simplest models use linear equations with weights and biases that can be trained. Models learn by repeatedly adjusting parameters to minimize the errors in their predictions. By outputting probabilities, models tell us how confident they are in each prediction. These simple ideas power countless applications, from spam filters to medical diagnosis systems.